Hello, and welcome back to Physics Chat. Physics Chat is a show where we talk to real-life researchers at the forefront of their research and learn about what it's like to be a modern-day physicist. My name is Susanna, and I'm back with my amazing co-hosts, Fox and Sergi. It's great to see you both, and I'm really looking forward to chatting with our next guest, Nikolas. Nikolas is a second-year PhD student at the University of Birmingham, researching metamaterials. He's not an astrophysicist. Nikolas, you are our first non-astrophysicist on the show. It is so good to have you. How are you doing?
Thank you for having me. I'm doing great.
Nikolas is actually a friend of mine from university. We shared lectures in the first couple of years of uni, and even though I was on the physics and astrophysics course, I think you were on the straight physics course, right?
Yeah, I was.
So, apart from meeting me and our other friends, what was the highlight of your time at university?
I think doing physics, it's a subject I really enjoyed, and you, Susie, but mostly physics.
Brilliant. So do you have any advice for someone wanting to study physics at university?
I think just go for it. It's a lovely subject. You won't be doing what you did in high school exactly. You might find it a bit more mathematical or a bit more computational, but it's lovely. Most people that go to physics enjoy it, and I think you should just go for it.
Do it! Just do it!
I love that advice. Just go for it. You can do it. So, as we did a lot of studying and chatting together, I know that you're very good at chess. So it's time in the episode to ask my random question. If you had to be a chess piece, what would you be and why?
I think I would be a king, not for the reason you think though, because kings are pretty useless in chess most of the time, but pretty good in certain situations. So I think that describes me.
Amazing. And what about you, Sergi?
It's a difficult question, but I think I would be a bishop because I like how it moves diagonally and it can move any length and go through all the pieces. I like that. I think I know which one you would be, but can you confirm that for us, please?
Me, I think I'd be a queen because
Yeah.
I just seem to be everywhere and anywhere, and just sort of, I think, as you all know me so well. Anyway, what about you, Fox?
I guess I would have to go with a knight, just because I have always been contrary, and I like being contrary. So that's always fun. Anyway, I would like to discuss what you are currently researching. So can you briefly describe your research, please?
So without going into too much detail, I think my research can be described in one sentence as using machine learning to design a branch of artificial materials called metamaterials.
Right. So what are metamaterials? We've had a lot of astrophysical objects that we understand, but this is very different. So maybe you could try and explain it to us cosmologists in a way that makes sense.
Yes, of course. So basically, you have to, I'm sure you guys know how light works. You have a wavelength, and it's like a wave propagating in space. And that wavelength is an electromagnetic wavelength. So it interacts with electromagnetic materials and most materials. So a great example is silver, how or any metal, it's shiny. So that's because of electromagnetic properties. The leaves are green because of electromagnetic properties. And people in late 20th century started wondering, what if we could make materials that use those properties and make unnatural phenomena happen? They started designing things that are smaller than the wavelength of light. And by changing certain parameters in those small structures, let's say, you were able to get strange properties. And the first time they called a metamaterial was for negative refractive index. So that means that if you look into that material, your side of vision after entering that material goes into you back.
Wow, that is so cool. So what sort of properties do metamaterials sort of have then?
So one of them is the negative refractive index, that you change the direction of light. The other one is cloaking. So if anybody has seen Harry Potter, where he just puts the invisibility cloak over him and he goes invisible. So you can actually do that with metamaterials. Not as fancy. It can only work for certain frequencies or colors, but you can make things disappear.
So do you think that the invisibility cloak in Harry Potter, would it be something possible in the near future?
No, sorry to Harry Potter fans. But
Same.
So there is two things. First of all, research is focused on things that are actually useful, and metamaterials are used a lot in medical research and in communications. For example, in wireless communications, you use cloaking to shield certain communication components like antennas that can be harmed from certain frequencies, but need to work in others. So using cloaking, you can get the frequency you want to go through, but then the frequency that could possibly interfere with your signal to go around it. It's pretty difficult to get it through the whole optical range because you're talking about a lot of frequencies. And it's not as useful in terms of real life applications. It would be cool, but I don't think it's.
Okay, so if I understood correctly, for now, what we can do is pick a specific frequency, specific wavelength, and we can make things invisible in that frequency. And if we wanted to build the invisibility cloak, we would need a much bigger range of frequencies, and we're just not there yet.
Yeah, so to summarize what a metamaterial is, we change materials on their sub-wavelength scales to affect the properties that we see from them on a human scale. Like, that's such an amazing feat of engineering. Very interesting. So something I wanted to ask you about that you said you studied is, why do we study them computationally? Why do we not just design them in a lab?
So we do sort of design them in a lab. Some in the early 2000s, machine learning wasn't as spread around, and people did calculations by hand, and the first metamaterials were calculated by hand, right? But as machine learning became more popular, we started realizing that it's very good at changing parameters to achieve a certain goal. I mean, it's exactly what we do in metamaterials. We try and change things like the refractive index just to get certain response. And with machine learning, it's able to do everything at once, basically, and we don't have to do the calculation. So we're giving it a go, and we'll see if that's better by hand or by machine learning.
So we're going to ask you a lot more about machine learning in a second, because we think it's very interesting, and that's what you're doing, right? But before we go there, I just have so many questions about the applications. So I wasn't aware that metamaterials were able to do these things, right? But it makes you wonder how you could apply it to many, many areas of real life. So for example, one that I was thinking about is art. So when you go to the museum and you look at a painting and you say, oh, wow, this is a beautiful painting, you can ask, okay, but what is it really, right? Physically, what is it? And it's just a collection of materials, normal materials, which in this case would be the paint, and they are arranged in a very complicated and specific pattern, which would be the painting, such that when you shine light towards the painting and it bounces back and you see it, then you say, wow, it's beautiful, right? But that's with normal materials. And you say that we can create materials, we can design them such that they behave with light as we want, right? We can basically choose however they behave with light. So do you think it would be possible to create art with these metamaterials?
Funny you say that, because people, without realizing it, have been doing it for centuries, actually. A great example is stained glass. So stained glass has a lot of nanoparticles in it, I believe gold or silver. And depending on the size of those nanoparticles, they actually get those bright red, bright green colors, just because they put structures in the glass that are smaller of the wavelength of light. So you could argue that's sort of the first metamaterial, even though it wasn't called a metamaterial. They didn't really know what they were doing, but it's been used in art for centuries, especially in churches.
Nice, interesting.
And I think there is a cup that's really, really old, and if you shine a light through it, it changes colors. But yeah, they've been doing it for ages, actually. Yeah, it's a great question.
Okay, so they were doing it without knowing what they were doing, but now that we know, like, people should be creative and start using it more.
Exactly. Who knows what's going to happen?
Well, let's get back to the machine learning, because that's something I'm very passionate about. So could you tell us what machine learning is?
Machine learning is basically computers using very sophisticated statistics to create, I guess, statistical models of certain either physical situations, physical parameters. And you can actually use those statistics to create a pattern or to change parameters in your physical system in order to achieve what you want. It has been used in speech recognition and in image recognition. And all those things are basically algorithms along with statistics that make computers understand what they see. You shouldn't use the word understand, because it's just statistics and mathematics, but I think I'm allowed in this case.
Yeah, I know. It's always annoying when the machine learning algorithm in Instagram gives me posts I'm not interested in. But yeah, that's so cool. So obviously there are applications in the real world, like Instagram, image recognition, like a lot of our phone and devices use machine learning. But how do you plan to use machine learning in Metamaterials?
So there is quite a range of applications of metamaterials. The two main ones is optimization algorithms and neural networks. So neural networks, they look at a bunch of metamaterials and they see how each metamaterial does what. And then once you train them and they see how metamaterials work without knowing any of the physics, you can ask them to get a specific response from that, and they will give you the metamaterial that you want.
So what exactly is a neural network? From the name, it sounds like something to do with the brain and something to do with connected nodes. But is there anything more specific than that?
Basically, neural networks is a bunch of little connected equations, one with the other. And you create this map where you put the output of one equation into the input of another, and you change that using different parameters. It's basically trying to approximate a very complicated system, a very complicated equation with a bunch of little small ones.
It's based on the Hubble and Wilson experiment, where they had a cat and they put the cat in front of a screen. And they put different lines on the screen at different orientations, and they measured the cat's visual cortex. So that's the front part of the brain. And they just noticed when the cat was stimulated in that part of the brain. And the cat was only stimulated at particular angles. So I think it was that one or that one, I can't remember. But it wasn't all of them. It wasn't stimulated at all. And this sort of came from the idea of this sort of hierarchical idea of knowledge, or how the brain processes things. So it goes from like simple lines and then goes through various neurons to create a more complicated picture. And so this has been taken into computer science in the form of neural networks. It is, again, very much to do with loads of simple maths going into a more complicated function. Thank you so much for being on Physics Chat. It was so interesting hearing about machine learning and metamaterials. And I look forward to the day that invisibility. Oh, this is going in bloopers. Why can't I say
at the end have a collection of all the attempts to say invisibility? Please, can we have that?
Hopefully one day we can get the invisible.
I waited for longer.
I give up. I can't say invisibility to save my life. Thank you so much for being on Physics Chat. It was so interesting hearing about machine learning and metamaterials. Who knew about invisibility clothes? And I hope one day they're an actual thing that we can buy. Let us know in the comments section, if you could be a chess piece, what would you be and why? We would love to hear from you. But for now, from everyone at Field of View, we hope you have an amazing day and goodbye. Bye.
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 I think you should just go for it.
For now, from everyone at Field of View, we hope you have an amazing day and goodbye. Bye.
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 I will do that again.
Bye.